Welcome to Chapter 3, Delivery of Contrast Media for Multi-Detector Computed Tomography. In this chapter, we're going to discuss the proper delivery of iodinated contrast and how important it is for multi-detector computed tomography. There are advantages from the fact that we can scan so fast. There's a greater coherency of the contrast bolus, and there's the ability to reduce the contrast dose. All advantages can be nullified, though, by improper contrast administration. The disadvantages from these faster acquisitions is that it's less forgiving, and it is possible to miss or outrun a contrast bolus. One of the big questions is, when do you use IV contrast? I asked a radiologist, and his answer was very short. In general, you always want to use it. He said the more appropriate question would be, when don't you want to use it? He said head CTs for trauma and a renal stone study. And for aortic dissection, you always want to do it with and without IV contrast. Let's talk about how the contrast circulates around the body so we understand what's happening. The first pass of the contrast is a denser enhancement, and it's less diluted. It travels from the veins at the injection site, right here, to the right side of the heart, there, to the pulmonary arteries, so out and up, to the pulmonary veins, back into the heart, the left side of the heart, to the arterial system, and then you reach the equilibrium phase, and this is after the contrast medium circulated throughout the body. It re-enters the right side of the heart. All of this is called the arterial enhancement phase. Now remember, to catch the optimal bolus in the pulmonary artery with the path the dye takes, inject it through a right anticubal injection site. It's easier to time the injections and keep the bolus together with a right arm injection. Let's talk about some contrast administration protocols. There are some main variables. First, let's talk about the scan timing. And there's two different ways to time the scan. You can do a test bolus method, which uses a small test injection, multiple low-dose scans that are performed over the artery of interest, and then the scan delay is determined by taking the time that it took to reach peak enhancement of that vessel, and then you add an additional small delay factor of a few seconds. Then you go back and do the actual injection itself. Then there's also what's called the bolus triggering method. There is no test injection. You just go ahead and begin the injection. Multiple images are obtained over the artery of interest, and then the scan is determined in two ways. Either when the contrast density in the artery exceeds a predetermined Hounsfield unit, the scan is initiated automatically, or you can watch it, and when you see that it is the amount that you want and in the place that you want, you manually trigger it. Now, how do you choose this major vessel? Well, you want it as large as possible, especially for automatic. Smaller vessels can be used if you're going to visually trigger it. And you want it within or very close to the area where you want to scan. So how do you pick the contrast amount and density? Well, most of the time the tech does not determine this. The radiologist does. But it helps to understand how that's chosen. They consider the main purpose of the contrast injection. Is it something vascular, like a CTA? Then the objective is to achieve and maintain optimal artery enhancement throughout the scan. The good rule of thumb is that the contrast injection time should last for the scan duration plus a small delay factor. The injection duration, again, is the scan duration plus a delay factor. The delay factor, generally between 4 to 10 seconds, is a contrast buffer. Then to determine the contrast volume, you take that injection duration and you apply it by the injection rate. So saying that your scan, when you look at it, is going to take about 12 seconds, and it's down low around the renal arteries. So you want to add about a 10-second buffer. So that gives about a 22-second scan. Well, you're going to multiply that by the injection rate. So if you're doing a CTA, it would be 4. So you would need at least 88 milliliters of contrast for there to be a good scan, and that's an optimal patient. Again, it's going to vary on the patient. If their heart's not working as fast, it might take longer. The high density contrast is injected at rapid injection rates, but if you use a lower density contrast, if you inject it at even a higher rate, you can get the same visualization. Are you injecting and looking at a parenchymal organ? Well, you need good organ enhancement, and so you would use 100 mLs of 350 or 125 of 300. The timing and injection duration is less critical than for CTAs. And if you're looking at the venous enhancement of the organ, again, it's less critical than for CTA. The amount varies with the type of examination and patient factors. Lower density contrast is usually a 300, like Opti 300, Omnipaque 300, and a higher density, the number is going to be higher, 350 or 370 Opti. Similar peak enhancement, again, can be obtained by using lower density contrast at a higher rate or higher density contrast at a lower rate. Let's talk about injection rates and techniques. The injection duration affects the cumulative arterial enhancement and the peak enhancement. As the injection duration is shortened, both the cumulative arterial enhancement and the peak enhancement will be smaller. Standard injection rates for CTAs are 3 mLs per second to 6 mLs per second. You normally see it right around 4. The faster the contrast is injected, the higher the peak aortic enhancement